Hey guys, welcome to today's lecture. Today we're going to be talking about binary. Now, you might be asking yourself, what is binary? Binary is the use of zeros and ones. It is the language that all computers speak and understand. It is also what you're going to be transmitting across networks, ons and offs. So it's very important to understand what binary is and also how to convert binary into decimal. Now decimal is base 10, meaning that there are 10 options. Binary is base 2, meaning that you have the 2 options. So, in binary, you have 0 and 1, on and off. Now, in decimal, you've got 10 options, starting at 0, and then you work your way up to 9. So, the question is, how are we going to be able to convert between these two freely? Now, there's a really simple way to do it. What you do is you take and you create a table. You starting from right to left. You start with a 1. That is your first bit. Now, every time you increase a bit, you are going to multiply it to a power of 2. So the next one is going to be 2. And then you multiply it again by 2. So you've got 4, 8, 16, 32, 64, and 128. Now, after you get 8 bits, you've created a byte, or something in networking we refer to as an octet. This is a very important notation you need to understand, especially when we get into dotted decimal notation. So, every time you're going to convert a number from decimal to binary, you need to be able to jot down these numbers off the top of your head. I would strongly recommend when you're sitting for your CCENT that you create this chart very first thing, before you ever start the exam. Make sure to write down this chart right here. Alright, now we're going to do a quick conversion kind of to show you guys how it works. Let's say we have the number 107. Alright, we need the binary equivalent of 107. So, you start from left to right. First, you ask yourself, is 128 too big for 107? In this case, it is. 107 is smaller than 128, so we cannot use 128. We throw it out. We put a 0. Okay, the next number is 64. 64 will go into 107, so we need one of those. We're going to add it. So we've now got 64. So you subtract 64 from 107, and you're going to get 43. Alright, so now we can continue on. We have 43 numbers left we need to fill, and our next slot is 32. Do we need 32? Yes. So, we're going to put a 1 in, and then we're going to subtract 32 from 43, which leaves us with 11. Alright, so we're going to move on to the next slot. Next, 16. Is 16 too big to go into 11? Yes. So we're going to cross it out. We need to put a 0 in there. Now we've got 8. 8 is the next number we need. So we add an 8, subtract it from down here, and you've got 3 values left. 4 is too big. We need a 2, which leaves us with 1 left we need to fill, so we need a 1. So the binary equivalent of 107 would be 0110111. Alright. Next what we're going to do is we're actually going to take and convert binary back to a decimal number. Alright, so the binary number we're going to convert real quick will be 11101001. So, we need to convert this. First, we're going to fill it in up here. Okay, now all you have to do is anytime you have a 1, you can take and add that number together. So, starting here we've got 128, we've got a 64, we've got a 32, we've got an 8, and we've got a 1. So we can just add all those numbers together, and that is going to equal 23. Okay, so now you can continue on into your next column. You get 13 and then 2. So our decimal number that this equals is 233. There are plenty of other examples out there online, and I would recommend just maybe jotting down a few numbers on your paper and converting freely between the two just as practice. It's basic arithmetic, but it's good to know how to do it. Very important. We'll see you next time. We'll be talking about dotted decimal notation and the use of binary in networks.